Hibernate Envers is the easiest and quickest option for adding an audit log to your application if you already use Hibernate ORM or Spring Data JPA. It takes you less than 5 minutes to add it to your project, create your audit table model, and activate auditing for your entity classes. And in this video, I will show you how to do all of that. The great news is that you only have to add a dependency to Hibernate Envers and one annotation to each entity you want to audit. The default configuration handles everything else for you. However, this doesn't mean you're limited to the default settings. In fact, many projects choose to customize their audit log, and for good reasons, but that's something for another video. Let's start with the minimal configuration and see how far we get. Hibernate Envers is an extension to Hibernate ORM, so your project should already have a dependency to Hibernate Core, and you have to add a dependency to Hibernate Envers. That's all. Envers is now part of your project and automatically writes an audit record for every write operation you perform on an audited entity object. Now you have to define which entities you want Envers to audit. You do that by annotating each class with an audited annotation. And now there's only one thing left to do before your application has an audit log. You have to create a revision table and an audit table for every audited entity class. If you want to keep it really simple, you let Hibernate generate your table model. I do that in this simple example, but I don't recommend that for a real application. You should instead create your own scripts and use tools like Flyway or Liquibase to automatically execute them when needed. So, how are those tables supposed to look like? Hibernate Envers expects a refinfo table to store the revision information. These consist of a unique ID and a timestamp when the revision was created. Envers also needs an additional table for every audited entity class to store their changes. These tables match the audited tables and add a reference to the revision in which this record was written and an enum value for the type of operation performed. By default, the name of these tables consists of the name of the audited database table and the postfix _AUD. You'll see an example of those tables when we run this test case. And we'll do that right now because we already did all the required steps to use Hibernate Envers with its default configuration. You of course can and usually have to perform further customizations, which I explain in great detail in my Hibernate Envers course in the Persistence Hub. But for now, this is good enough to try out Hibernate Envers and get an understanding of how it really works. This test persists a new chess player entity object. As you can see here, there's nothing specific to Hibernate Envers in this test case. I only instantiate a new chess player object, set the first name and last name attributes, and persist it. When you run the test case and check the log output, you can see that Hibernate generated a refinfo table and a chessplayer _AUD table that match my previous description. The refinfo table stores the revision ID and the timestamp when the revision was created. And the chessplayer _AUD table has all the columns of the chessplayer table, plus an additional foreign key reference to the refinfo table, and a column describing if the record was written for an insert, update, or delete operation. Okay, let's scroll further down and check what Hibernate did when we ran the test case. It got a new value from the chess player sequence and stored the new player in the chess player table. That's what you expect when using Hibernate or any other JPA implementation. But these are not the only SQL statements the test case triggered. The following are caused by Hibernate Envers. It first gets a new value from the refinfo sequence and uses it to write a new record to the refinfo table with the revisions ID and timestamp. In a future video, I will show you how to customize the revision information and, for example, include the user who executed the business method or test case. In the next step, Hibernate Envers wrote a record to the chess player audit table. This is the audit record for the newly persisted chess player. So it's no surprise that you can find all bind parameter values used for the insert operation on the chess player table Also here when writing the audit record to the chess player audit table. In addition, the audit record included two additional pieces of information: the revision to which this audit record belongs and the type of operation audited. In this case, that's an add operation. If the test would have persisted multiple entities, Hibernate Envers would write such an audit record for every entity object to the audit table and link all of them to the same revision. Okay, let's take a look at another test case that does a little bit more. This one uses 3 transactions to first persist the new chess player, update it in the second transaction, and remove it in the third. As mentioned earlier, Hibernate Envers creates a new revision for every transaction that creates, updates, or removes at least one audited entity object, and links all audit records written during this transaction to this revision. So in this case, we expect Hibernate Envers to create 3 revisions, each of them with one audit record documenting the modifications of the chess player. These 3 transactions trigger a few too many SQL statements to check them all in the log output. However, we can easily check the results in the database using pgadmin. As you can see here, the refinfo table contains the 3 expected revision entries. That's one for each transaction. The chess player audit table also contains 3 records, all for the same chess player record, but linked to a different revision and documenting a different operation. The first describes the creation of a new chess player entity. The second, the change for the first name attribute, and the third, the removal of the entity object. Hibernate Envers models the type of operation as an enum, and as you can see on these 3 records, it maps the enum using its ordinal value, which represents the position of each value within the enum definition. As you saw in this example, each transaction that creates, modifies, or removes an audited entity object creates its own revision. But what happens if you change the same entity object multiple times within the same transaction? Hibernate Envers then creates one revision and only stores the entity's final state in the audit table. You can see that when running this test case. It first persists the new chess player entity. It then flushes the persistence context to force Hibernate to execute the insert operation. As I've explained several times on this channel, you should usually not trigger the flush operation programmatically because it prevents several internal optimizations. I'm only doing that here because I created a very simplified test case. And after flushing the persistence context, the test modifies the chess player object. As you will see in the log output, this triggers an additional SQL update statement. Here you can see these statements. Hibernate executed a SQL insert statement and then a SQL update statement for the record with ID 1. And as you can see down here, it only created a new revision entry and stored the final state as a persist operation in the audit log. Envers automatically writes the audit log for you, and that's a good start for most projects, but your users want more than that. It's not enough to only write an audit log. Your users also want to view the audit records for a given business object. So you have to get those audit records from the database, and I will show you how to do that in the next video.